Many analysts who are interested in building predictive models invest a lot of their time and effort in trying to understand how to best tune the parameters of the specific technique that they're using, whether that technique be logistic regression or a neural network. And they're doing this in order to achieve, of course, the best accuracy of the resultant model. Now, in this series of videos, we're going to look at some often overlooked approaches that can be applied in the same way to a wide variety of algorithms, and which may lead to better predictive accuracy. In all of our examples, we'll focus on improving the accuracy of a predictive model applied to a classification problem. Now, the first trick we're going to look at is called bootstrap aggregation, but also known as bagging. Now, bootstrap aggregation is a random ensemble method, and it's designed to increase the stability and accuracy of models. It involves creating a series of models from the same training data set, and it does this by randomly sampling with replacement the data itself. Sampling with replacement means that a specific row of data can appear more than once in the subsequent random sample. This means that each resultant model is effectively trained against a slightly different sample of data. The resultant predictions from the multiple models are then all combined together to create a single score. Let's have a look at how that works. In our example, we're going to be using a telco data set that looks like this. You can see it's actually only got 7 fields in it. Each one's got 1,000 records, and we've got a target field here called churn. The input fields include information about the usage that each customer made of different services provided by the telecommunications company. If we build a standard decision tree model against this, we just run that model, it's going to create this little nugget here that's already created, and we can then just test how accurate that model is. Now, you'll notice that down here we've got a partition node, and that means that the data itself has been split into 2 groups, a training and testing group. And you can see that the partition node here is specified as 70-30. So 70% of the data is used to train the model, and 30% is held back effectively for testing, which is a standard approach for checking the accuracy of a model. So we're really looking at the testing group here. We can see here in the training group it's 81% accurate. On the testing group it's slightly less accurate, 79%. And specifically, we can see that there are 66 examples where it's actually made a mistake, 66 records or cases in the testing group where it's incorrect. And these 66 cases are effectively shown here as false positives and false negatives, which are effectively shown here, this diagonal here. We can see that it's actually generally doing a pretty good job of predicting people who are in the F group, the false group, for churning, and a very good job at predicting people who are in the T for true group for churning. But really we want to minimize these two numbers, and by minimizing these two numbers, of course, they sum to 66. So the smaller the level of inaccuracy, the greater the accuracy. How can we do that? Well, let's see if we can actually create a bagging model to do that. So a bootstrap aggregated model. And if I just copy this actual node down here, so we're looking at a shade model, here's a decision tree model. We'll double click on it, and I'll just switch to the different method here. So you can see here we've got a standard method, build a single tree. You can see here I'm going to switch on enhance model stability, bagging. It does enhance the model stability. It also actually enhances the accuracy of it, and I can tell it how many of these models to build, how many of these bootstrap aggregated models to build, just by going down here and saying, okay, I want you to build 30 models. So I'm actually going to build 30 models. It does that, and it runs that procedure, and once it's done that, it's going to create a nugget just like it did in the standard model above that point. We can double click on it, look inside it, and we can see some information about these different models. So we can see, for example, how much better this bootstrap aggregated model is than the reference model being the standard model. We can see how many times different fields have been used in different models. We can see the level of accuracy of the 30 different models. Down at the bottom here, you can see they're varying in accuracy from 87% here to 79% and 91%. And what we're going to be doing, of course, is we're going to combine them all together to create a single prediction. The combining is done in different ways. You can see things like voting or highest probability win or highest mean probability. I'll just go with the default here, which is voting. And if I connect that up again to the analysis node as beforehand, we can compare and contrast it. Now it's saying that it's made mistakes 27 times. So the accuracy is now 91%, whereas previously the number of errors was 66 in the testing group and the accuracy was 79%. So that's using bootstrap aggregation or bagging to increase model accuracy.